Today we are going to be talking about this, the Easttester ET3240 benchtop multimeter. Now in today's video I'm going to give you guys an overview of it, show you its features, show you it working. I also want to talk to you about some of the design issues that there are with this product, and you do need to be aware of them before buying it. And at the end of this video I'm going to give you my thoughts on this device. Now I bought this multimeter myself for about $145. It took nearly 3 months to arrive from Banggood. If you don't know what a benchtop multimeter is, it is basically the same as a traditional portable one, but it is designed to be permanently fixed on your bench. It reads voltage, resistance, current, just like a standard multimeter does, but a benchtop one is powered by mains, but they generally have some extra features for data login and things like that as well. Now, just to explain why I wanted a benchtop multimeter, I'm in the process of actually redoing my electronics area, and I wanted something that was a permanent fixture that I knew that I could just hit the button, turn it on, and it would be ready to go. However, benchtop multimeters do come at quite the cost. They are much more expensive than standard traditional multimeters, and you are paying many times more compared to its smaller counterpart. Now, this one, as I said, cost me about $145, and that actually is very cheap compared to, say, models from Siglent or Regal. However, that cost saving is there for a reason, and you are seeing that in the quality of the device, the way it's actually put together, as I'll show you when we look inside, as well as some of its functionality as well. Now, before we dive inside, I'm just going to give you guys a walk around the unit itself. On the front, you will see a 3.5-inch LCD, which has got 4.5 digits of resolution. It's capable up to 22,000 counts, and it is designed to read all of the standard stuff. So it will read voltage and current in both DC and AC. It will read resistance, capacitance. It will also read certain limited frequencies. It will data log as well internally, and you can connect it to a PC for getting external data out of it as well. Now, overall, the front layout is fairly straightforward. You've got your control buttons on the side, the LCD in the middle, which you can also change the color of, and then the inputs on that side. You also get a set of probes in the box with this as well, but I have to say I would strongly suggest upgrading them because they do feel quite cheap. On the sides, you then have this integrated stand and carry handle, and then moving around to the back of the device, you will find our mains input, a fuse, as well as a USB port in the middle. Now, what I will say with the overall feel of it, it does feel quite cheap. It is a metal enclosure, but the front and back are plastic. It does have rubber edges on it, but everything does feel just a little bit loose. The handle especially is quite loose, and I do find that whilst it does double up as a handle and stand, it will collapse if you're not careful, and I certainly wouldn't trust it. My model also came in with a bit of a burn mark on the back of the plastic as well, which is a bit strange. Clearly something that's happened from assembly, but again, it is showing where that cost saving kicks in. Now, as I mentioned at the start of the video, there are some things you need to be aware of on this internally. These devices, whilst they are brand new, many of them actually have been reworked at the factory. There are some changes that they've made inside on the PCB, and there are some wires put around the board to actually make it work properly. Now, I will say before I show you this, I have no functional problems with my model at all, but it is clear that they have actually had to do some work on it before shipping it out to me to get it to actually work. Now, that is not something you would generally expect with a new product in this day and age, and it isn't something you would get if you were buying something like a Regal or a Siglent. Anyway, let's take a look inside. I'll walk you through what I actually found, then I'll take you through some of its functionality, and then I'll give you my thoughts at the end. So, taking a closer look inside, what we have is our mains input on the back here. This comes into the mains transformer, which is then outputted through these cables down to the main PCB. You've then got a loop down to this little section of the board which is separated off with the mains power switch. Now what is quite strange is the mains power switch is set right back, and they use this long plastic lever that you can see down here to actually activate the switch, and as I press it in and out you can actually see it kicking it in and out there, but it does make you wonder why they didn't push it all the way back down the front. Next to that you then have your fuse connection which goes to the back as well, and you then also have another fuse located under this little plastic cover over here. Now something I have noticed is that there are plenty of earth bonds inside the unit. We've got the main earth bonds located over here going onto this little screw boss on the side, and you have another earth bond over here as well, which is good to see. Now one thing I did notice when I first took it apart is that my transformer, whilst bolted onto the side, is very loose. So I would have liked to have seen that a lot tighter than it is, and that is something that we're going to have to take a look at. Then for the main board itself, you've got one PCB at the front, and then you've got this second PCB at the back. Now this one at the back is simply to interface to the USB port that's located on the back. On this model there isn't anything else populated, but you can see the empty slots for the 9-pin serial port, as well as other ports located over here, but they're not in use on this one. Moving in closer, looking at the PCB, initially everything looks fairly tidy. However, upon closer inspection, you can see that there has been some bodging or rework done around this area here and this area here. Now, if you haven't seen it, Steve Gardner from SDG Electronics has actually reviewed both this, the ET3240, as well as the ET3255 model with the 5.5 digit display. And Steve found that both this and the 5.5 had rework in this area, but the 5.5 inch had much more rework up here around the resistor banks to give it that increased accuracy. And when he actually reviewed both models, he didn't recommend buying the 5.5, and whilst both of them have had some rework, this one was the better buy overall. Now if I do take a look around, what you can see is obviously we got the fuse holder which I showed you earlier over here on the left hand side. There is a glass fuse and it is soldered in place, so that's going to be a complete pig if that ever has to be changed. You can then see this area over here which has had some rework, and what we have is a wire jumper been put across from that IC there to that IC there, and then there are two more wires that come off some resistors by the look of it down here, go around to the other side of the PCB and are soldered there. It's also clear to me that there's been some rework in this area here as well as this area here as well, because I can see that there's been heat and flux, and you can see that they've actually had to do something there as well. Now this problem down here is clearly because they have changed the circuit or they've changed a component, which means they actually have to wire it slightly differently, and the chances are that they've manufactured tens of thousands of these PCBs and they're having to get through them before they actually do a design change to be able to put this on properly. They may never actually redesign the PCB and simply do this rework as part of manufacturing. Over here it's clear that either something hasn't taken properly when they've done the initial board build, or they've had to replace some components after building it to make sure that it actually worked correctly. Now this was brand new and it literally hasn't even been on for an hour yet, but it's already clearly had a lot of work put into it. Whilst technically none of this changes how well it will work, it is extremely frustrating to buy a new product and find that it has had to have been reworked to get it to actually function correctly. But you do have to take that into account when you are buying something like this, and you are saving substantial amounts of money. In the UK, I paid about £123 for this benchtop multimeter. If you were going to buy something from Siglent or Regal, I would be paying 3 or 4 times that. So everything does come at a cost. You just have to decide for yourself if you're willing to accept this kind of design and this kind of reworking over the cost of one of the more expensive ones, and really it comes down to what you're willing to accept to use. Other than that, everything else looks fairly tidy. The PSU and everything is well grounded. I've got no concerns around that area either, and all of the wires up to the main front board look okay as well. I will tilt this up now just so you guys can have a closer look at that area too. Looking at the front PCB, you can see you've got the main ribbon cable, which comes up from the main board at the back, and you've got this second ribbon cable coming from the main PCB. There is an ARM processor on board this as well for the display, and then you've got this very thin ribbon cable, which looks like it's going round to the actual LCD itself. There looks to be a thermistor located down there in the bottom corner, and then over here, you've got your main input posts, which come in off the front and go down to the main board, and overall that all looks fairly tidy and it's fairly well soldered, so I wouldn't expect to have any issues with any of that down there. As I mentioned, there are a number of processors on board this. The one on the front for the main display board looks to be an STM32F103, reading that upside down, and there is another processor over here which has had its labeling removed next to another IC here which has also had its labeling removed as well. Now that would suggest that they're using standard off-the-shelf microprocessors rather than ones dedicated for testing applications, and they've removed the marking on them just so people don't really know what they're doing. Looking around the back of the PCB, everything looks fairly straightforward. There's no components really on this side at all. It's simply all of the traces as well as everything being soldered down. You can see over here with those two wires appear from the other side of the PCB, and they're soldered onto the two components there. Now what is noticeable is just how dirty the PCB is. There is residue located all over the back of it. Clearly they haven't cleaned it that much after the main manufacturing process. Okay, so taking a closer look over the meter and actually giving you guys a bit of a demo of it in action. Now, obviously on the left-hand side here, you've got all your inputs. Now, I'm currently in the top on the middle one on the right hand side, and this is our traditional inputs for using it with our voltage, current, resistance, capacitance. You've then got your various other inputs. So at the bottom you've got your current inputs for up to 12 amp or 100 milliamp. You then got the low for that and high for sense as well. Now the nice thing on this is that it does have little tracks that show you where you need to put it depending on what you actually want to do. For this we're going to simply use it in the traditional voltage mode, so we don't have to worry, we are in the correct positions. So if we fire the meter up, you can see that it's got a fairly quick boot time. Actually, it's literally about a second and it is up and running, ready to go. Now the display itself pretty much shows all of the basic information you need. Obviously in the center you've got your readings. Now it's come on to DC voltage. You can see a little dot flashing in the top center, and that's our trigger, and it's telling us that it's in auto trigger. And then at the bottom we've got our input scale, which is currently showing at 20 volts. It's telling us what the trigger level is. Now some of this stuff is all adjustable on the front. So for instance, if I adjust this, this adjusts the trigger speed. If you've not used a bench multimeter before, it's worth noting that you've got a manual trigger option on this. So rather than it just read, you can actually set the trigger to slow, medium or fast. You've then got the voltage scale adjustment, as you can see, with the up and down. And if I actually just hit it, say to AC and then back to DC, we can hit auto, and then it will actually auto sense the input rather than manual. But I can change that manually if I wanted to and override, but we could then hit auto again and it will read as normal. Now obviously up here on the right hand side we've got all of our traditional modes that we read from. So we've got DC voltage, DC current, AC current. We've got resistance, continuity and diode, frequency and temp. Now one of the nice features of this is it does read up to 20 megahertz in frequency, and I will show you a little bit on that on my scope in a minute, and we'll actually have a look at my 1 kilohertz oscillator just to see how that looks on this as well. And then down here you've got your various other buttons for adjusting the trigger. So you've got your auto or your manual trigger, you've got your AC/DC, your duty hold, your limit, your save, your memory options and all of that. Then along the bottom here we've got things like our stats, which brings up info like the maximum voltage and things like that. You've got your max B giving you dB, dBm, and then you've got rel there next to it as well. So I think the first thing we will do is take a look at the voltage in real time. So what we'll do is we'll pop it onto my bench supply at the top. I've currently got this set to 5.7 volts. We'll dump both probes in. Not as easy as it actually should be with these leads because they're not particularly great. However, if I balance them in place, you can see that the meter is now reading the voltage from the probe, which is 5.746 volts. If I now adjust the voltage on the power supply to say 6, you can then see the voltage adjust on the display. Now, as I said, we've got the option for the trigger speed. and if I do that fast, you can see that it will react faster as the voltage changes. So we're sampling much faster than you would be normally. And then if we go down to say slow, you can see as I adjust the voltage, there's a bit more of a delay in how fast it actually picks up. Traditionally, I would use it in the middle position just to give us the ideal output. Now, I'm not going to actually look at measuring AC voltage or DC voltage, AC voltage or DC current and AC current in this. I'm just going to have a look at the voltages. Now, we can manually set the scale, as I said just now, so we can go to 200 volts, 20 volts or 2 volt. So for this, we'd want it on 20, but if we wanted to go back to auto, we can hit the auto button there. We can also manually trigger it as well. So if we wanted to trigger it singly or individually, we can do that with the button on the front. As you can see, we've stopped triggering, so I can actually take the probe out and it will hold the voltage on the display. If I then hit the manual trigger again, you can see that it's stopped. Or if I go back to auto, it'll start picking it up again. And then if we pop the probes back in, not as easy as I said it should be, but pop them back in, you can see that it will start to pick the voltage back up and we're all okay and back to normal. Now, as I've said, we've also got some things like the stats. So if I bring up the stats, you can see it will show the maximum and minimum voltage, the average voltage, the standard deviation as well. And then you've also got the samples going up at the bottom and how fast it's actually sampling. So if I actually knock that up, you can see I've changed it to fast. And you can see the sample rate is going up much quicker. And if I actually slow it down, you can see the sample rate is much slower. We can then hit things like dB. It'll give us the dB reading, dBm. Just quickly showing you this save option that is on it as well. What we can actually do is click save. And it will begin to actually save the info on the unit. And if I actually adjust it now and adjust it down to replicate it, actually having an adjustment, so I'll go down and then replicate it back up, you can see that it is counting up and saving the individual steps. So if I now just hit stop and go back into memory, you can then see that we can actually step through these and look at what it captured at that moment in time. So if you wanted to be able to actually look at the data a lot more closer in detail, you can see that we are able to step through it as the data was changing right back to number 1. So if I go back to number 1, and you can see actually we've got the frequency one in there as well. So it's got multiple memories options within it too. And we can actually step up and go all the way through back to where we'd recorded to. So that is the basics of reading DC voltage. Now, as it is a multimeter, it can also read other things as well. So we can do resistance. So if I hop it over to the resistance mode, we can do simple resistance check. So I've got some 10K resistors here next to me. So if I put them on the probes, you can see that we're getting on 9.8687 kilo ohm. If I go to that one, because this is a pair of resistors in series, so we're getting 19 kilo ohm as well. We can also measure capacitance on this as well, which is a nice feature. So we can actually have a look. I've got a small cap here, which is just a 220 microfarads, 35 volter. So I'm simply just going to pop the probes onto him. And again, show you that in real time. And as you can see, it's come up with 216, 217 microfarads. So again, a nice simple reading, easy to check the components with as well. Now, the other thing I said I was going to show you guys was the frequency and period input, because it will actually measure frequency as well. Now to do this, I'm just going to turn on the oscilloscope a moment and let that kick in. Now it allows us to measure frequencies up to 20 megahertz. Now I haven't actually tried it up to that level myself, but I have tested it on the 1 kilohertz input that I have on my scope, or the output on my scope I should say, with 1 kilohertz input, which is used for setting the probes. So if I actually just drop it onto the scope and pop it on the 1K input, you can see it's popped straight on as I'm reading from the probe on the front of the scope, and you can see that we're getting our 1 kilohertz on the display straight away. Now, the final thing I just wanted to show you guys was the menu system. So I've pressed the menu key and you can see that we can scroll up and down through the menu options. We've got some adjustment options within it. We can adjust the language. So you can see we can actually switch through the languages. The nice thing with it is you can switch through but get back to the language you want really easily. You've got the beep, open and close. You've got the lights. You can actually adjust the display. And then you've got the interface to change how you want it to actually look on the display as well. I do quite like that one. That reminds me of an old computer display, actually, that one. I do like style 6, but style 1 is that green style, which is that traditional one there. For me, I think I'll stay on style 6. I quite like that one. I do like how that one looks. And it allows us to actually look a bit more like my unit at the top as well, so it sort of matches that one. So you do have the options within that as well. Now you do have this cal option too. Now if I take it into DC voltage and go into it, I haven't looked at this. If you press shift and on the auto stroke cal button, it gives you the option of going in, but I've not really looked into that any further than that. But I do believe you have the options to go in there and calibrate it. But again, it isn't something I've looked into at depth at this moment in time. Now, overall, I do have to say, for a cheap bench multimeter, it does have quite a lot of features and it does work very well. And overall, I have to say, I am reasonably happy with it. Something I will say to be aware of is on this stand, like I've got it here, as you can see, I've got it mounted with my power supply on top because I am a bit limited on bench space. However, be aware this isn't very strong and it could collapse. I think for me, what I'm going to do is put just something underneath it to be able to hold it up a little bit as well. So to give you my thoughts on the EastTester ET3240, the price is extremely good for a benchtop multimeter. $145. If you compare that to something like a Regal or Sigland, it is half the price, if not more. However, that does come at a cost, as you've seen. They do feel cheap overall, and the fact that the device has been reworked does leave a bit of a salty taste in my mouth as well. I have to say though, functionality wise, for me, it is working exactly as I would expect, and it is doing what I would expect it to do. So from that aspect, I am happy. Would I recommend buying one of these? Well, my thoughts are this. I would say you are much better putting $150 and getting yourself a decent portable multimeter than getting yourself a cheap benchtop one. If you absolutely have to have a benchtop multimeter, then try and get yourself a Regal or a Sigland. However, if you can't stretch to that and you are willing to be okay with the fact that it's been reworked, then going with this is okay and it's probably worth a look. My one, I will also add, did take nearly 3 months to arrive. So if you are going to order one from Banggood, do take that into account. That is it for this video. I hope the information in it has been useful. If you've liked what you've seen, please do consider hitting that subscribe button and don't forget to hit the little bell next to it as well. Finally, I do a live stream every Sunday night, roughly 10 PM UK, 5 PM Eastern on my second channel, which is Mads Live. There is a link to that in the description of this video as well. Please do check that out. Please do stay safe. Thank you for watching, and I will do another video again soon.